where the function itself equals 0. Sit down, Carter. But in the case of this one, I can't factor it, so it makes it hard, right? It makes it hard to find those zeros. So the only option I would have to do is to find another factor or graph it. But in the case of this one, we did this one yesterday. This is a terrible first example. I've messed up already because Carter is distracting me. We divided by x. Yes, we set it equal to 0 to find the zeros. We divided yesterday by x minus 3, and let me just come over here. This was given to us yesterday. And we found when we divided it, and we do a little synthetic division here, 9, 4, 12, 0. We find that when you divide it, you're left with 2x squared plus 3x plus 4. The point I'm getting to here is when you multiply two factors together, that gives you what you started with, right? Does that make sense? Okay. If I did 6 divided by 2, I would get 3. I could also write this as 3 times 2 equals 6, right? Well, over here, what I've really done is divided this by x minus 3. Would you agree? Why? See how I put the 3 on the outside, the opposite sign? That means I divided by x minus 3. Yes, this is a problem we worked yesterday. But I'm just kind of piggybacking on what we did yesterday. Yes, the blue problem. I just said 2x cubed minus 3x squared minus 5x minus 12. Maybe I need to call the tutor. Divided by x minus 3. Okay. And because I didn't get a remainder, then I know that it's a factor. Apparently I need to back up even further, right? Yes. You could try to slash this one, but it wouldn't slash. It wouldn't factor. Because I could take an x squared out of this. It'd leave me with 2x minus 3. Nothing to take out of there, so it leaves me with 5x plus 12. And since those aren't the same, it doesn't work. All right, so no remainder means I have found a factor. Okay, and the nice thing about factors is I can put them together and they multiply to the original polynomial, right? In other words, if this equals 2x squared plus 3x plus 4, then I could say, well, x minus 3 times 2x squared plus 3x plus 4 equals what I started with. Agree or disagree? Yes, I'll give you a second. Y'all don't remember this from Algebra 2? Okay. Does everyone in here understand that if I divide by something and I get no remainder, that's what it means to be a factor? And two factors multiply together to give you what you started with. I'm fixing to show you. Does everybody understand that? Do you understand that what I did up here is I took this polynomial divided by x minus 3 and got 2x squared plus 3x plus 4. Do you then see how I could rewrite and use the two factors multiplied together to give me the original polynomial? I'm literally rewriting, which is all factoring is rewriting. So I'm finding a way to factor it down is what I'm doing, okay? All right. Now, I say all that because the whole point of this is that I am able to find these zeros, right? So I could set it equal to 0. So now I'm back over here. So if I want to know what are the zeros of this, I would say, well, when does it equal 0? Well, when this equals 0, that's kind of hard to solve unless I graph it, right? But if it's broke down this way, can you now find all the zeros? I hope you can. Why are you going to distribute?
Oh, you got the quadratic formula.
Whatever you get when you do the quadratic formula, because it doesn't factor, right? Y'all, are you following me? Nothing, nothing multiplies to 8 but adds to 3, so it's not going to factor for us. I'd have to do quadratic formula. Right. Right. The quadratic formula. Yeah. Opposite b plus or minus the square root of. B is 3, so it's 9 minus 4 times 2 times 4 all over 2 times 2. And then I just simplify under the radical first. 9 minus 32 is negative 23. Two answers, one answer. The I, because it's negative under the radical. Yes. Sorry, I didn't go quite far enough back. I apologize. So, okay. I'm going to give it to you today, but that's all we're doing in class tomorrow. Okay. I started by saying PRZs, but I haven't done any PRZs yet. This one was, I found the zeros, but I had a starting point here. I knew that x minus 3 was a factor because I'd already done it. But the question is, what if I have this polynomial? Is this the same one? This is not the same one. No. And I said, find all the zeros. And you said, well, I know whenever I find zeros, my first step is to set it equal to 0. And then I try to factor if I can. But the problem here is it doesn't factor, right? Because it just doesn't factor. All right, so my question is, what do? I have to find a factor to start with. So what we do, this is where PRZs come in. What do PRZs stand for? Do you remember? Rational just means it can be expressed as a fraction. There are possibilities. You kind of didn't. Yeah. There are possibilities. It means they may or may not be, and I have to test them to see which ones work. Do y'all remember doing this now? I hope so. This is where we do plus or minus factors of the constant divided by factors of the leading coefficient. Well, in the case of this one, what's the constant? And so what are the factors of 2? What's the leading coefficient? What are the factors of 3? So I need every possible combination of these numbers divided by these numbers. So the PRZs for this one, and don't forget your plus or minus. Plus or minus, I'm going to do all of these divided first by 1, and then I'm going to do all of these then divided by 3. If I had another number here, I would do all of these divided by the next. Well, I'm doing plus or minus, so it could be either one. So no, the negatives don't matter. 1 divided by 1 is 1. 2 divided by 1 is 2. I'm done with that one. 2 divided by 1. Oh, sorry. I went the wrong way. I went the wrong way. What? Divide all. Now I'm going to divide all these by 3. I'm finished dividing by that one. Now I'm going to divide it by 3. Sorry. 1/3 and 2/3. However you see it best to make every possibility, just make sure you do all the possible ones. These are possible zeros. They may or may not be a 0. Those are factors of the constant divided by factors of the leading coefficient. So I could do it one of 2 ways. I could plug it in, because we talked about that remainder theorem where if you plug it in and you get 0, it's a factor, right? But the problem with that is if it works, if it works, I need to know what I get when I divide it. So it's a little bit easier to go through synthetic division to test these. So then you know you remember. I took all of these and divided them first by 1. Because those are factors of the constant. And then divided by factors of the leading coefficient. Actually, I should say PRZs are first, then test to find a 0. How am I going to test? I'm going to test by synthetically dividing. Because where I get a remainder of 0, then I have found a good one at that point. So we'll just start with 1. It doesn't. Synthetic division is fast. It is. I was lucky enough to find it on the first time. Okay, look at the problem, the starting problem, right? I asked you to find the zeros of that. I just tested a place. You do them all until you find one that ends in 0. I got lucky and the very first one I tried worked. Same thing for -1. You'd still come through into -1, 3, 4, -5, -2. See, -1 didn't work. You see why it didn't work? I didn't get 0 on the end. I have to have 0 on the end because it has to be a factor. Once you find one that works, now I want to write it as a multiplication problem. So just what I showed you, remember 2 factors multiplied together give you what you started with? Not 1 times, but this is the 0, so what would the factor be? There you go. X minus 1 is the factor, because I got the 1 out here, times, what is this? 3x squared It still equals 0 because I still want to know what does x equal when this equals 0. It does equal, I just rewrote it a different way. I'm trying to get it completely factored down so I can solve. Okay, so at this point, now this is an easy one. This is not really a pre-cal level, and this is an algebra 2 level. But we'll go ease into it. So now at this point, I want to factor what I can. So I'm going to say factor, or I might even have to PRZ again if it doesn't factor, okay? But the goal is to get down to where I can set each piece to 0 to find the zeros. And for this cubic, how many zeros should I have? 3. I should have 3. That includes any repeated ones because we talked about multiplicity, right? But I should get 3 solutions. Because what's the degree of f of x? This tells you how many zeros you should get. It's the degree. The degree tells you. And then 1 less than the degree tells you what? How many humps it has. They might not be factors. But they're a possibility. If you had 3x minus 1 equals 0, what would x equal? 1/3. Are you saying you don't understand how it would work doing synthetic division and it come out to be 1? Which one works, Mac? What, negative 1/3? If I did this, what's negative 1/3 times 3? Negative 1/3 times 3. Negative 1/3 times negative 6. He was just saying he didn't understand how 1/3 would work if you divided. All right, so back over here because we digressed a bit. Okay. Can I factor the quadratic there? In other words, does anything multiply to 6x squared but add to 7x? Yes, what is it? 1 and 6. 1x and 6x.
Oh, they don't know how to factor. So you multiply the first and the last.
He just missed the first number. He just missed the first number. Robert, did you just miss the first number or you just don't know how to factor? Yeah, which? Okay. When you factor a quadratic, are you listening to me, Robert? You multiply the first and the last together. What do you get? 6x squared. You have to find 2 things that multiply to 6x squared, but they have to add to 7x. Okay, so that's the 1x and the 6x, right? So if I gave you, I can't tell you the new stuff if you can't remember how to do this. We're going to do a little bit more on this today. But if you don't remember how to do it, how am I going to? What? Plus x plus 6x plus 2. All I've done is rewritten this by adding 2 terms together in the middle. Now I slash it. What's the greatest common factor of 3x squared and x? X. If you take an x out of just these first 2 terms, what is left? 3x plus 1. The middle sign stays. What can you take out of the last two? 2. What's left if I take a 2 out of those two? If you've done it correctly, these should match. Then I take that whole chunk out. So I say x minus 1 times 3x plus 1, and what's left? X plus 2. Is it all coming back to you now? That's okay. When I didn't really cancel them out, I took them out. I factored them out. Like I backwards distributed that whole chunk out. So like if this was xy plus 2y, and I told you to factor out the greatest common factor, what would you take out? A y. What would it look like when you took it out? But you only wrote y one time. Where'd the other one go? I did the same thing. Only my y is 3x plus 1. Yeah. Exactly. Precisely. Robert, precisely. And I solve each one of them. So what are my solutions now? 1, negative 1/3, and negative 2. The pre-cal portion of this is actually not the hard part, it's the algebra 2 part. I tell calculus all the time, it's the algebra 2 that kills everybody all the time. We'll help them. All right, here's the new stuff. Y'all got this down now? Those are the zeros. But now understand, it could be, depending on what my polynomial is, when I get to step 3, I could end up with something like x minus 1 times 5x to the 7th plus 6x squared minus 9, and that doesn't factor, right? So I'd be back in PRZ territory again, and I'd have to PRZ just this one, find the factors, break it down, so the x minus 1 is still there, but then I'd have this one broke down in a linear plus something else. Well, that's not quadratic. What's a quadratic? A degree of 2. So it works with every quadratic. So I'd be back to, how do you find PRZs? Factors of the leading coefficient divided by So 1, 3, 9, 1, 5. So my PRZs would be 1, 3, 9. Of course, plus or minus in front of all these. 1/5, 3/5, 9/5. And then I would start seeing which one of these would divide, because it's these divided by these. And I'd be back to square one working through those. This one's not going to work out because I just made, what? What? Y'all okay right now? Y'all need to go take a lap before we add the new stuff? Okay. Hi! Let's say so listen, Liz and Linda, all right, we talked about these PRZs, right? And we've talked about checking these PRZs, but sometimes I can have a whole big long list of PRZs. So it would be really helpful if I knew like an interval of numbers that it had to be between, okay? And I can actually do that, and I can prove it with a theorem that I'm going to give you. let's say, for instance, let's say I divided this by -2. Okay, if you divide by -2, because that's one of the PRZs, right? Factors of 8 divided by factors of 2. -2 is one of those numbers, yes? I'm giving you a starting point here. But the PRZs here, 1, 2, 4, 8, 1, and 2. So PRZs would be 1, 2, 4, 8, 1/2. 2 divided by 2, 4 divided by 2. 8. So yes, you can. Those are the PRZs. So I'm just showing you that this is included in the PRZs here, okay? So let's say I picked a -2 to plug in and checked it to see if it's a factor. Okay, well, I go through in PRZ. 2, -4, -11, 22. What does that give you? 14? -28, -14, +28, 36. Is that a factor? No, or it's not a 0, which means it's not a factor. But this tells me something very important. What did you notice about the numbers on the bottom? They're alternating positive and negative. That's exactly right. Positive, negative, positive, negative, positive. And what I'm actually going to say instead of positive, negative is that I'm alternating between non-negative and positive. No. Negatives and non-negatives. Because what I'm getting at is zeros don't count here. Zeros would go for either way. If there was a 0 in here, it would count for the alternating signs. They don't really apply, is what I'm getting at. So if you divided and you got, say, on the bottom you got 10, 0, 0, -3, 1, -6. Positive, negative, positive, negative, positive, negative. You can count them either way, is what I'm getting at. All right. When this happens, this tells me that -2 is a lower bound for my zeros. What in the world does that mean? That means my zeros, whatever they are, they'll never go past -2 below. They'll never go below -2. That's the smallest it'll ever get. Because alternating signs. So alternating signs is a lower bound. Really what you'll do, you won't be coming up with these as much. Your problem will say something like, prove that -2 is a lower bound for f of x. Yeah. What, Mel? How do you find the upper bound? Is that what you're asking? I'm fixing to show you. All right, so there's lower bound, right? Upper bound, and I'll just do this one the way it would probably be given to you. Prove that x equals 5 is an upper bound. Okay, well, if I divide by 5, 2, -7, -8, 14, 8. Let's do this one and see what this looks like. 10, 3, 15, 7, 35, 49, 45, 45. What do you notice about these? They're all positive. Upper bounds happen when it's all positive. That's the new stuff. You see how easy that is? The PRZ is the algebra 2. The new stuff is the boundedness here. So what this problem might look like is it might say, given f of x, prove that all zeros occur on the interval -2 to 5. I would divide by -2. If the signs alternate, then that proves that. I would divide by 5, and if the signs are all positive, then it's the upper bound. Does that make sense? You didn't. I was just showing you. If you happen to pull a PR, because we'll get to some stuff like that later, where you'll come up with the bound yourself. If you use that as a, see, not a bound. This one, however, all positive, upper bound. And look at your actual zeros, right? They never get bigger than 1. Then it's nothing. They either have to be all positive or they have to be a bound. They either have to be all positive or alternating signs. No, it'll literally, this, let me just write, this is the way it is on your test too. Huh? Y'all, do you know how I know? Because whenever it's tilted ever so slightly, it dims, and I can see it out of my peripheral vision. I can see the screen dim a little bit. It's not a psychic power or anything. I can't just tell. Prove that all the zeros of this function lie between, so prove that all zeros lie in the interval (0 to 1). Absolutely. Good job. What's 0? Wouldn't what just be 0? I need to test this one first. If that really is the lower bound, what's going to happen? Alternating signs. So 0, 5th, 4th, 3rd, 2nd, 1st. Constant. Then yes, you count the zeros. They can count either way. Mm-hmm. So yes, that proves lower bound. Check upper bound. Yeah. But it doesn't matter because you're going to look at what you have. Let's see. All positive. So yes, that works. So how does this help me with PRZs, and how does this even tie into PRZs? Well, for this one especially, if I listed out my PRZs here, what are the factors of 6? 1, 2, 3, 6. What are the factors of 10? 1, 2. So let's list the PRZs. PRZs would be 1, 2, 3, 6. Now I divide everybody by 2. 3 halves. Now I divide everybody by 5. Now I divide everybody by 10. 2/10 is 1/5. That's already on there. 3/10. Yeah. Why is it helpful that I have an upper bound and a lower bound? Look at everything that eliminates. That means now my PRZs are actually, it eliminates anything that's not between 0 and 1. So I could do 1, I can't do -1, 1/2, 1/5, 2/5, and I'm only taking the positives. 3/5, 1/10, 3/10. I've now drastically reduced my, this way, I've now drastically reduced my possibilities. My lower bound is 0, my upper bound is 1. Yeah. You would say it's not because the signs don't alternate or because the signs are not off, and then you'd be done. It gives us a range that we have. For right now, all you're going to be doing is showing, you'll be stopping right here for right now. Say again. That's still, but that's still an upper bound, like it never goes over. By upper bound, it means it never goes above this number, and it doesn't ever go above 2. But it's just the fact that then you didn't pick the lowest upper bound, if that makes sense. No. Because this was given to you. If this wasn't given to you and you had picked 2 first, remember these are just possibilities. They're not actuals. So if you'd have done a 2 and you got all positive numbers and this was not into play, then you'd say, okay, well, I know it can't be over 2, so I'm going to take everything less than 2. There's still possibilities, but it's just not. And then maybe you tried 1 and you went, wait, 1's also all positive. Wait, that means 1's actually a smaller upper bound, so I can use 1. If I tried a half and it worked, then I could take it down to a half. All right.